Hey guys, EST here, and I'm going to teach you how to turn your car into basically a generator of lots of watts of alternating current to run basically anything in your house in an emergency. So right here we've got an 800 watt inverter, a 400 watt inverter, and a 200 watt inverter, just for size purposes I want to show it off. So this one, you got the two DC power hookups, and then the two alternating current, just standard house sockets basically, at least in America. So in this video, I'm just going to use the 800 watt inverter because why not, even though I end up running a 65 watt laptop off it and that's it. But that actually is very inefficient, so you might want to plan what you want to run first and then buy accordingly. Now there's one more thing I should mention, and that's something you should do right now. Look up your car's alternator's specifications. And I still have the same alternator that it came out of the factory with, but my car's like over 10 years old, so you can probably shave 10 to 20% right off that, maybe 10%. With all the electrical ratings in this entire video, you don't really want to get close to the limit. Always build in a little headroom. So I believe according to the specs online, my alternator is capable of doing 70 amps at idle. And it should have idle and then max, and max is usually like above 2000 RPM, basically like, cruising speed. So you want to look at the idle amount, and then the average voltage for an alternator and just a whole car's central circuit is 14.3 volts. That can vary. If you want to be safe, you can just put it at 14 flat, but most of them run 14.3, then they get higher based on temperature drops. So 70 amps, we'll just say 60 because I really do not want to draw more from the battery than the alternator can feed in, and like I said, the car's over 10 years old. So safely 60 times 14.3 is 858 watts. So there you go, an 800 watt, perfectly capable. Wouldn't want to go much higher than that, although you could go 1,000 just because and then draw about 700 through it, which would be, still just fine. So before I get into what inverter to buy and the different types and that kind of stuff and, all the calculations, let's just show how you do it. So the next thing you need are just a little pair of jumper cables. These are 10 feet, look like about maybe 4 to 8 gauge, probably 8. You can find charts online, but basically like 8 gauge cable over, I think 20 feet could draw well over 800 watts safely. So you want to clip it on negative first, I guess, but until it's on the battery, it doesn't really matter. And then positive second, there we go. And make sure they don't touch. So that leaning over that way, that's something you don't want to do. So I ended up just moving the cable kind of that way to keep them split and then just running it straight between them. That worked pretty well. So if you got a pretty big inverter, it probably came with some battery clamps, but they're usually like 4 feet long and not thick enough. One thing you never want to do is keep the inverter anywhere in the engine bay. The engine bay, the whole dang car vibrates, it can move, it will not stay where you put it, and things get hot. Also, you don't want that positive terminal touching anything because the entire car and everything metal in it is grounded. So positive to ground, not good. That will cause lots of sparks, the cables will light on fire, and then your battery will explode. So you want to put it on like a small, preferably non-conductive table, right in front of your car like I have. So you want to connect it to the battery there. You can see I uncovered the positive, had a little insulating cover, that red thing there, but you always want to go negative first to prevent immense sparking. So it might still spark a little bit, so don't get scared and pull it off and touch something stupid. And like I said before, make sure that that positive clamp does not touch any surrounding metal. It is all the negative terminal. The whole car is the negative terminal. If you were to, say, touch that positive clamp to the hood, it's probably enough electricity to immediately weld it to the hood, which will make it very difficult to pull off. The levels of electricity we're talking about here and just sheer amps are insane. Be very, very, very careful. So in an absolute emergency, okay, whatever, but for now, we're going to use a multimeter, set it to DC voltage, of course, and then 20 watts, or 20 volts max, because it should be, between 12 and 14. And I realized you can't really see anything there, so I corrected it. So about 12.8, very nice battery, should be above 12 volts, obviously. Okay, so theoretically, your alternator could be putting out like 50 amps, you're drawing 55 amps, and you will slowly draw down from your battery then. When it hits a certain amount, your inverter should turn off, but I guarantee a battery at 10.4 volts, which is the shut-off voltage for this inverter, that would be at risk of not being able to start the car until it was charged from a different source. Or hey, jump it from another car, jumper cables, but still, just don't do it in the first place. So running like a 65 watt laptop, you're good, whatever. But looking up the specs ahead of time and making sure that you're well within the acceptable limits for your alternator's output level. Okay, you're probably good, but to be extra, careful, you could just come out every 15 to 30 minutes and just remeasure the voltage and make sure it's not going down. It will go down slightly as your alternator heats up, but it shouldn't be lower than really even like 14 volts. If it's into the 13s, the car will probably still start, obviously, because the battery sits at 12.8 volts. But that means you're really going the wrong direction there. Also, you might overstress your alternator. I'm not sure if you can really do that at idle, but I wouldn't want to try it. So remembering to keep checking on it is a very good idea. Also, checking that the car isn't out of fuel. Most modern cars, by the way, can idle for many, many, many hours, like probably beating out a generator. It also helps that I have a 14-gallon tank in my car. But I spent an extra $3.50 to add on this fun little toy. And this is just a simple little volt reader. I think it goes like 5 to 24 volts or something. There's a little LCD, little chip in there that tells me exactly what the voltage is, so it monitors it at all times and draws next to no electricity. And since we have positive and negative going into a solder point on the back that goes into a printed circuit board there, I insulated the entire back with heat-proof, cold-proof electrical tape. So I just clipped it onto the battery where it fit there, and 12.7 volts. Now, by the way, it should be a little bit above 12 volts while the car's off, and it should be a little over 14 with the car on. The battery can do a little bit above 12. The car's alternator will operate at a little bit above 14. That's why. So I started the car, and as you can see, 14.3 volts. Nice, right on the dot. So now you can go ahead and flip on your power inverter. Mine's pretty obvious because it has a really loud cooling fan, but also it has a little green LED, and then it has a red alarm LED, where if it gets overloaded, undervolt, whatever, it will usually play an alarm, or if it's really severe, it will just be the red LED. So we're plugging in the adapter for my laptop there. So we're officially going from DC to AC, and then back to DC. 12 volts to 120 to, I believe 19.5 is what this laptop runs at. Terrifically efficient, I know. Now, one thing to make sure of is every single electronic thing in your car that you can possibly turn off is turned off. So, like the radio, any kind of center console computer thing, the seat heaters, the headlights, which you can see I left mine on. That's what that flicker is. They're really cheap LED ones. But every little bit helps. I mean, non-LED normal headlights are like 33 watts a side or something in that neighborhood. So, there goes 33 watts away from your idle output capability of your alternator. Okay, it's a bit late to mention this, but I probably should have said the alternator spins and generates electricity, and it's on the main belt on your engine. So with the car not started, or with just running this power inverter on just a battery and that's it, it will drain down the battery. With the alternator spinning and continuously creating, 60 amps at 14 volts, you're going to have a continuous supply, potentially, of quite a lot of electricity. That will sort of continuously charge the battery, but really, since the battery's at 12.8 and the alternator's higher, it will just pass through straight to the power inverter, and the battery will just be like a little buffer that kind of sits there. Now, you might have noticed the positive clamp is still leaning over because that cable is so darn heavy, and it's probably within an inch of the negative one. Boy, that is not good. They're insulated, but you can never be too careful. So jumper cables are not absolutely ideal for an inverter since the posts are so close to each other, especially on a small inverter. That would be horribly dangerous. So you could rig up just your own cable. Just buy some 4-gauge, 8-gauge cable, whatever. 8 should be sufficient. And then pop one of these ring terminals on one of the ends, and then you can actually buy those clamps, and then you just crimp them on with a little crimper. You can even solder on top of that to make sure it's a really good hold, and then put heat-proof electrical tape around it just to really hold it on, or heat shrinking that you can melt with a lighter or a heat gun. So in other words, you can build exactly what you need for the job, and then those two posts on the inverter, you might have noticed they're threaded, they came with caps. So you would screw the cap on, and then the ring terminal would be snug up against it, and there you go. That's actually how it's meant to work. One more thing is don't buy an inverter with the cables embedded, where they just kind of go inside and that's that. You do want external posts so that if anything happens to the wires or they degrade over time or they're not thick enough or not long enough, you can home make your own little solution. Just don't go too far. If you were to, run your car out in the driveway and then you ran, 30 feet of 10-gauge cable into your garage and then pulled 800 watts through it, I think that is a little bit too long of a distance for 800 watts if you're pulling the full amount, and it will melt the wires. If you just get copper 4-gauge welding wire, you can pretty much do whatever you want, but you only really need to be about 6 or 7 feet away from your engine bay anyway in most cases. Also, the thicker the wire, the harder it is to attach to a ring terminal. Also, make sure the ring terminal itself is rated for the amount of amps that you're going to be pulling. So, once again, divide by the voltage, about 14 volts, and then make sure your ring terminal is rated for 60 plus amps in this case. You might need a really, really thick automotive grade, solid brass one, or something pretty nice. All right, so as you can see, we got the laptop running there, and of course, it's running Windows updates, because of course it is. But more importantly, it is running. Like I said, it's only drawing about 65 watts max. Usually at idle, it's between 20 and 35 watts. And then when it's full-blown doing something plus charging the onboard battery, it can reach, 65 cap. So if you want to know how much an appliance draws, you can look on the label on the back. So this is from a Dayton Shopvac, actually. I wanted to choose this because it's so unbelievably high. So 120 volts AC, obviously everything in your house runs on AC when you plug it into the wall. And it's always going to be 120 even if it doesn't say it. Now, if it says VAC, that's just volts alternating current. That V and then the squiggle also means volt alternating current. Straight line means DC, by the way. And hey, that's what an inverter does. It takes DC and makes it into AC. Then it says 60 hertz. In America, everything is 60 hertz. Just don't worry what that says. DC, by the way, is positive is positive, negative is negative. Great, let's flow some electricity. AC is alternating current, which means it alternates positive and negative, and it flips at 60 hertz, 60 times per second. That will be important very shortly in the video. So anyway, 120 volts and then 12A, 12 amps is how much it draws. And every single electrical device that is legal in basically the world will have a label on it somewhere, usually on the back or the bottom or near the cord. And it will say how much power it draws, because if you put too much power through something, it could light on fire or you pop a breaker or whatever. So you have to know. So the way that you, the consumer, knows is if they put a label on it. So you would just straight up multiply 120 volts times 12 amps. And you would find out quickly that this vacuum cleaner draws 1,440 watts. Yeah, I wouldn't even run this on an inverter, to be honest. I mean, you can get 2,000 watt inverters. They exist. It would probably run this vacuum just fine. There is a heck of a draw when you first turn it on to spin up the motor, though. But usually 2,000 or 4,000 watt peak for a quarter second, so, you know. I will say, though, the alternator on your car is definitely not going to be able to keep up with this. And see, that's where people say, oh yeah, my generator, it's like 4 circuits, 5,000 watts between them. There you go. Yeah, that's because a generator doesn't move a car. It just spins a small engine, a very, very small engine, and then all it does is spin an alternator. And then it feeds it into an onboard inverter. So it's basically the whole thing that you just built with your car, but by itself. The problem is a good generator is over $1,000, and a cheap generator, oh, they're nothing but problems. They're defective. You got to change the oil, like legit, read the manual, about every 20 to 30 hours in some of them. And if you want like a top of the line one, you're going to pay so much, you might as well just buy a car at that point. The only benefit is the truly enormous output. But they're loud. If you leave gas sitting in them, it'll ruin them because like it'll get sorted, and then you got to use like octane booster or shake it up to mix up the ethanol. It's a whole thing. I would just do it this way. It's easier. I mean, the foolproof way to do it would be like solar panels into a very large battery bank of lithium and then that into an inverter and, you know, run part or all of your house off it, but that's a different video. Plus a cheap system like that with the panels, $2,000 on the low end. So that's why this is the budget way to do it. A really decent high wattage inverter is about $150. Jumper cables, I mean, I usually buy them at the thrift stores, secondhand. Those are like nothing, they're like $3. Brand new, they're like maybe $15, $20. A lot of copper in there. Don't get cheap Chinese ones. They are copper coated iron usually. They will rust and they are never the gauge they say they are. And then your car is whatever your car is, and then fuel. So it's like, oh, you basically got a generator for like 100 and change. Oh, and that 400 watt inverter, I think it was $40-some. So, I mean, hey, really decent emergency power. And by the way, some stand-up freezers, like those big, 2 foot by 2 foot freezers that are about 4 feet tall, some of them, the condenser will max draw 350, 300 watts. Same with like a mini fridge. I've seen a lot of those that only draw like 150 watts. I mean, geez, you could run that off my 200 sitting there. Once again, the when the condenser kicks in, the initial pull is quite high. So you might want to pad it pretty good. And remember, refrigerators and freezers don't run all the time. Far from it. They probably run like 5% of the time, depending upon how hot it is outside and how well insulated they are. Whereas like you flip on a vacuum cleaner, that is constant pull of 1,440 watts. So let's look at like a smaller, like an electronic device. Not a lot of electronics draw much. I mean, I guess if you consider like a blender or a table saw an electronic, okay. But this original Toshiba power adapter right here, it's kind of hard to read in this photo, but it says input 100 to 240 volts AC. It's got the squiggle for AC, 1.3 amps, 50 to 60 hertz. So that will work on any outlet in any country. That is the point. Then they only have to make one. So they have got some crazy flexible like chips and capacitors and, step up and down coils and VRMs and all this crazy stuff inside of there. So you can throw just about anything at it and it will spit out, as it says their output 19 volts, 2.37 amps, and that's DC. So you might think, okay, well, 120 volts AC and then 1.3 amps it says at 60 hertz, cool, multiply it out 156 watts, but that's just incorrect. I'm not even sure why they wrote that, to be honest. I mean, technically this power adapter is just like a glorified transformer with some other stuff in it to regulate the voltage. And it truly, like if you actually meter it, will draw 45 watts. So in this particular case, you would want to look at the output. I know the draw is always a little bit different than the output. Usually it's before the loss based on any kind of heat leaking or resistance, whatever. But the first number is a range. It's so wildly inaccurate and it's built to run in any country. You just can't use it. So 19 times 2.37 is 45.03 watts. And that is about how much it would pull. And these tend to be pretty efficient, especially at not full draw. So maybe an extra 10% on the top for heat loss and that kind of stuff. Usually not even. So if you just assume, okay, about 50 watts drawn at the inverter max, that should be a good number. And you're well within the inverter's capability almost regardless of what you buy if you're just running this particular Toshiba laptop. Also, for the record, the laptop will not draw 45 watts constant. It will only do it when it's working really hard. At idle, a lot of modern laptops are about 10 watts, believe it or not. So like if I run and go look at my toaster real quick, oh wow, it's not labeled at all. That is extremely legal. And I just looked at this random back massager thing I got. It's 20 watts. That thing goes, seriously. You could put sandpaper on it and start stripping the paint off stuff. That thing is heavy duty, but instead of saying voltage and amps or input output any of that, they just wrote 20 watts right on it. So things do tend to be a lot or a little. Like my laser printer, I believe is 1200 watts. A space heater, usually 1000 to 1500 watts. An average cell phone charger, 2.5 to 10 watts. A typical microwave oven, 900 to 1200 watts typically. And a little upright triple lamp that I use for videos, that one's simple, just add up the wattage of all three of the bulbs. All three are LED. I believe they're all 18 watts draw too, so that is not much. Like a power drill, that's usually in the 750 watt range. Things just around the house typically take either really not a lot or really a lot. So you could think, okay, in an emergency I would want to run this, and this, and then, power strip into the inverter. Add it all up and then buy accordingly. So let's talk about inverters because this is one thing that is very important. There are three types of inverters as far as you're concerned. There's the cheapo square wave ones, there's the modified square wave ones, which are still pretty cheapo, and then there's the true sine wave inverters, and then there's the Chinese counterfeits. Oh, did I say 3 categories? There's actually 4. If it's on Amazon or eBay, it is shockingly cheap and it comes from overseas or comes from a clear, Port of LA importer, and it says true sine wave, it is almost definitely not true sine wave. And even if it was, they usually tend to be just really poorly put together and failure prone, which is not what you want in an emergency. If you want to know what brands and models are very, very reliable, find people on really the internet in general, but especially on YouTube, that do professional solar installations and, power walls, battery walls, that kind of stuff, and just look at what they're using or look at their review videos because they do not buy stuff that fails because they do installs for people professionally. Okay, y'all be mad if I don't mention one. Renogy, they make all kinds of crazy stuff. They're famous for being really good. If you want to pay a little extra, in my opinion, kind of needlessly, but it is very, very, very high quality. You could get a 1000 watt true pure sine wave inverter for about $190 right now. We got the COVID shipment stuff, we got all that, but these things are meant to just be tough as nails, not care what you throw at them, voltage fluctuations, whatever, not turn off and complain and crap. You can get a cheaper one that's more built for automotive RV use, that's kind of okay and not quite as flexible, but also not very failure prone, probably closer to 100 to 140. And you can get a super ghetto, who cares, just Chinese Wonder one for $70, by the way, but I wouldn't recommend it. Oh, if the website, the box, whatever, doesn't tell you the low voltage shutoff voltage and the high voltage, safety shutoff range, don't buy it. I've seen super high end ones that are 10 volts on the bottom for the shutoff and 18 volts on the top. So, you're probably never going to surge the thing. But, if you're shopping for high end ones, don't buy one that's supposed to be a 24 volt one or a 48 volt one for a solar power wall because it won't run at 12 volts. Or I should say 14.3 in your car. So the waves, well, it's science time. This is really simplistic though. The one in the middle there, sine wave inverter, but just basically a sine wave. That is what's coming from, your house outlet. It is flipping the polarity. Positive is on top, then positive is on bottom, 60 times per second in the US. That's 60 hertz. And it's doing it as part of a wave. So halfway down the wave, you're not at 120 volts. You're at 60 volts. So with alternating current and a true sine wave, you do reach 120 volts peak and then it flips, and but it's not 120 volts the whole time. You can see why the one on top, square wave, might be a little bit of a problem. Now this is a simplistic way to do it because you just put a little chip in the inverter that says flip it 60 times a second. So the entire time it is 120 volts positive for 1/60th of a second, and then the next 1/60th of a second, the entire time it is negative 120, or I should say just the poles reverse. Same thing, really. There's 2 wires. You get it. So if your device is expecting it to not be full 120 volts of pushing electricity through it for the entire time, but that's what you're sending it, that could be bad and it could not be bad. Pretty much everything goes through a transformer, and that cleans it up a bit, but there's really two-ish things that you would never want to run on a square wave inverter, and it's about to describe most of the things in your house. So anything really particular and sensitive, like an old television, it would start to get scan lines and just do funny stuff because it just isn't getting what it was expecting. And it like sprays electrons onto the screen with an electron gun, and it's just, that sounds disruptible, and it was. Same goes for like projectors and stuff, but the one thing you really want to watch out for is motors, because it will quite literally overspin them and just, burn them out pretty much. With the polarity going full-blown 120 the whole entire time, and then 120 backwards and 120, it never dips. There's no low point. So you're technically pushing it harder than it expected. So a 700-watt power drill could literally be running like 800, 900, 1,000 watts. I don't even know. I mean, theoretically double, so you start melting wires, you start breaking transformers, but certainly it would spin faster than it thinks it should, or that it was built for. So if it's like 10,000 RPM, well, now it's 12,000 RPM on a square wave, and yeah, you're going to burn it out. So what would be considered a motor? Just about anything. I mean, a blender, like I guess not something with heating coils, like a toaster, but I believe, and I've heard both ways on this, but I wouldn't want to break it, like a portable air conditioner unit. They use a pump, and the pump theoretically runs on some sort of mechanical motor. So if you ran like an AC unit with an AC compressor and a motor driving the piston or however it works to compress the gas, it could do it to a hard build up pressure, start blowing pipes, overheat the motor, all that stuff. So if you had like a variable speed drill, just don't pull the trigger more than about half and you'll be fine, right? I wouldn't risk it. Just don't buy square wave inverters. Now, a lot of electronics can clean it up. A lot of like a laptop wouldn't really care. Sound systems typically would. Something with an amplifier, you might start getting some funny sounds and funny things happening there. So yeah, true good sine wave inverters can be like double the cost, but I would get one. I mean, if you want to run anything safely and don't want to start blowing appliances up, I would get one. So the bottom one is a modified sine wave inverter. So instead of just flip it 60 times a second, okay, cool, done. You've got, it's going to try to step it down, but it's like a variable timing thing. So instead of 60 hertz, it's really the chip inside of it is running multiple steps, but you don't know how many steps. And yeah, it's a good average, but it's still not clean. It's still not a true sine wave. So still, if it was like an audio system or something very, very sensitive, you might see a distortion, hear a distortion in the output. Like a lot of old CRT televisions did not like any kind of thing that wasn't a sine wave. And that's a pretty generous graph on the bottom. I've seen ones that say modified sine wave, and it's like 3 steps. So it's like, within the 60 times per second flip-flop of the polarity, we're going to split it up and subdivide it by 3. We're going to go like 120, 90, 60, 30, 0. It should average out, and it should be safer. I've never heard of people saying they have problems. But if you're going to buy a modified sine wave inverter, they cost more than square wave. Just buy a sine wave. You're already like within 10% of the price anyway. And also the modified sine wave label might be lying. There's a lot of counterfeits out there. So buy from a reliable seller, reliable brand, something that people have vetted, good reviews. If somebody hooks up some advanced electrical, detection equipment to it right in front of your face on YouTube and says, here's a review of it. Oh, look, it is a true sine wave. Or, oh, look, they're lying. That's the best way to find out. Some guy on Amazon saying, I put a curling iron into it and it didn't blow up. It works for one day, which is how long they waited to write the review. That's not a very accurate or good review. I mean, I've seen some reviews where they're like, it says 1,500 watts. This thing shuts off at 600. It's just simply a counterfeit. So just research what you buy. So like I said, would I buy a generator or would I buy a really nice like 1,500 watt or even 2,000 watt inverter? I would buy an inverter and just hook it up to my car. I mean, the only problem is if it's inclement weather or it's raining out or whatever, but I could park the whole car in my garage, pop the hood and then run like a 50 or 100 foot extension cable into my house and run my fridge or whatever. That's the plan right now. I'm literally describing my setup. So, I mean, with the generator, you have to gas it up, make sure it's, good to go, maintain it upwards of every day if it's a cheap, crappy one. And you hope it doesn't break, and like any generator under 1,000 probably is going to break pretty quickly. Some of the somewhat respectable brands where you're like, oh yeah, I've heard of them. They make tools and stuff, and they make electrical equipment. Great. Yeah, they just slap their name on and take a licensing fee to some like Chinese, manufacturer with zero quality standards. So even if you've heard of the brand name of the generator, it's still probably not very good. Now for, 900 to 1100 bucks, you can get that, the famous generator that everybody has, the really small light portable one that Honda, the little red one, and it's a Honda and it's an actual Honda and they are amazing. And they run for like 10 years and I think they usually don't even require oil changes, or if they do, it's really infrequent. Those are cool, but like a really beast inverter is like 150 bucks and those generators are, roughly $1,000. It's a no-brainer to me. And your car can hold more fuel and be used to go drive and get more fuel. I guess while it's an operation, you can't move the car. Somebody could disconnect everything and steal your car, but also somebody could disconnect and steal your generator. Generators are overpriced, they're stupid, they're hard to maintain, and you already bought a car. It's just, I would never buy one. I'd spend an extra 500 bucks and go solar before I bought a generator. Unless you really just say, screw it, I'm going to get a big ass generator for $2,000 and it's like a 5 or 10,000 watt. It's got like 8 circuits on it. They're all 20 amp and I could run everything in my entire house and then just keep fueling it up and use my car to go get fuel. Okay, I mean, it's nice. I'm not saying it's a bad solution. I mean, the sheer output horsepower is nuts. Speaking of that, I mean, my car is, I think like 130, 140 horsepower or something like that. You might be wondering, horsepower is watts. What's the difference? 1 horsepower is about 750 watts. So how many horsepower is your car generating at, 6,000 RPM on the highway going 100 miles an hour? Well, probably whatever the engine's rated for, quite a lot. But how many horsepower is it generating idle? Well, it's not moving, hard to say. It would be virtually impossible to actually measure that. But, your alternator at, 60, 70 amps and then a 800 watt inverter to it, that's basically 1 horsepower. It's probably idling at 1 horsepower or more, so you don't really have to worry about like the car running out of power. It's more about the alternator running out of power. And modern cars, a lot of them will idle at like 800 or 900 RPM or something like real low like that. The alternators are built for it. They're engineered and designed for that. And your fuel is going to last really, really, really long. Now, a big 6-liter giant, van, bus, truck, you might get a little different results there just because the engine is so needlessly large. But on a smaller car, like a sedan or a coupe or something, something modern, ballpark, you could probably idle it for 2 days on the low end. The average car in America right now is about 1/5 of a gallon of fuel per hour. But keep in mind, that varies drastically. So I think I hit on everything. Obviously, don't let the carbon monoxide coming out of the exhaust build up. That goes for generators and for cars. So if you're in the garage, you might not even be able to safely really step into the garage unless the wind is really blowing or you got a fan going, which, how are you powering the fan then? Boy, that would be the pinnacle of inefficiency. Don't do that. But, in an emergency, maybe, take a downspout off, put it on the exhaust and just, it's metal, probably won't melt. And, get it 10, 15 feet down the driveway as far away from your house as you possibly can. Heck, tape 2 of them together. I mean, the tape will probably melt because of the heat, but, it's something. We're talking about an emergency, not like if you were to do this daily, which I don't know why you would. So, everybody knows emergency situations, start ripping stuff off your house and get the duct tape and improvise everything. That's why I did this with jumper cables. Those should be in your car anyway. So if you have any remaining questions, I'll do my best to answer them in the comment section down below. Otherwise, thanks for watching. Don't forget to leave a like and subscribe for more amazing videos that are very crucial information to your safety. And maybe even send this video with anybody like on social media or email or whatever that you might think this would help or they might be interested in. Because as I always say, if your inverter suddenly breaks, maybe they saw this video, they got prepared, and you can go bum some electricity off them. So thanks for watching, and I'll see you guys next video.